Hello everybody and welcome to today's lesson on properties of parallelograms. Today our objective is we will be able to verify characteristics of parallelograms and we will use properties of parallelograms to solve problems. So let's first talk about the definition of a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. A quadrilateral means it has four sides and both pairs of opposite sides are parallel. That means this side has to be parallel to this one and this side has to be parallel to this one. And then we have a parallelogram. And if we have a parallelogram, we have a number of properties that come from that. The first property is that both pairs of opposite sides also are congruent. Not only are they parallel, this side also has to be congruent to this side, and this side has to be congruent to this one. The next property is that one pair, or at least one pair of opposite sides, has to be both parallel and congruent. So if, for example, we take this side here, this not only has to be parallel to this side, they also have to be congruent. We don't have to know anything about the other pair of sides, but if one pair of sides is both parallel and congruent, that's enough for us to know that it's a parallelogram. Now let's talk about angles. Both pairs of opposite angles have to be congruent. Both pairs. So angle P has to be congruent to angle R, which is opposite of P, and Q has to be congruent to angle S, which is also its opposite. Consecutive angles are supplementary. Remember, consecutive means next to each other, and supplementary means that they have to add up to 180 degrees. So if I just pick some numbers here, let's say for example angle S measures 100 degrees, then that means that angle P has to measure 80 degrees. 100 plus 80 is 180, and then together they measure 180 degrees, and that means they are supplementary. But that also goes in the other direction. Angle S also has to be supplementary with angle R. So R also has to measure 80 degrees, and together they measure 180 and are supplementary. By the way, if P is 80, then R has to be 80 anyway, right? Because opposite angles are congruent. We just said that before. So, and our last property is diagonals have to bisect each other. Remember, bisect means cut in half. So the way those two diagonals go, let's mark them in here, the diagonal from P to R and the diagonal from Q to S. Where they meet, they have to cut each other into two congruent pieces. PR is cut into two congruent pieces, and QS is also cut into two congruent pieces. Let's practice using these properties on some examples. Decide whether the figure is a parallelogram and explain why or why not. I want us to look at the first two examples together. Example number 1, is this a parallelogram? We have one pair of opposite sides that are parallel, but that is not enough. We need two pairs, so the answer is no. Only one pair of opposite parallel sides. In example number 2, we have these two opposite sides that are parallel and these two opposite sides that are parallel. So the answer is yes, this is a parallelogram because both pairs of opposite sides are parallel. Okay, now let's look at examples 3 and 4. In example 3, we have one pair of parallel sides and we have one pair of sides that are congruent, but it's not the same pair. It has to be the same pair of sides that's parallel and congruent. So this does not have to be a parallelogram. It could be also a trapezoid, even though it doesn't look that way. But remember, we can never go by just the look of our diagram. We have to use information that's given. So this is not a parallelogram because it's not the same pair of sides that's parallel and congruent. In example 4, however, you see the parallel marks and right underneath the congruent marks. So yes, this is a parallelogram because one pair of sides is both congruent and parallel. Parallel and congruent. It's one pair of sides that fulfills both criteria. Let's look at examples 5 and 6. In example 5, we have two pairs of opposite sides that are congruent, as shown with these congruence marks. So, yes, it's a parallelogram. Both pairs of opposite sides are congruent. And in example 6, we don't have sides marked with anything. What we have marked are our diagonals. The diagonals cross each other and both of them are bisected, giving each of them two congruent parts. So the answer is yes again, this time because the diagonals bisect each other. And now in examples 7 and 8, we have some markings on angles. So we have angle measures given, and let's see these two angle measures. What do they add up to? 117 plus 64 is actually 181 degrees. So the answer is this is not a parallelogram because the consecutive angles are not supplementary. If we look at example 8, however, and we take our measurements, 120 degrees plus 60 degrees is 180, so that works out. And in the other direction, we got 120 plus 60 again, so it's got to be 180 also. So this one is a parallelogram because the consecutive angles are supplementary. Okay, I hope that you're starting to feel a little bit more comfortable with these properties now. And now we're going to move on and use them for some more examples. If not, just go back and rewatch the first part of this tutorial one more time. In these examples, we're supposed to find the value of each variable in the parallelogram. So we're given the information that these are all parallelograms. That means all our properties apply, and we have to use them to find the values of the variables. We have several things marked here. We have sides marked, and we have angles marked. Well, two different ways to distinguish that. Angle measures do have that little sign for degrees, of course, and the side measures are on the outside. So let's look at the sides first. What do we know about the sides of parallelograms? Opposite sides have to be parallel, and opposite sides also have to be congruent. Since we're supposed to find the values, we need to go with the sides, the lengths of them, and therefore we use the property that opposite sides are congruent, because that means that 3x plus 4 has to be equal to 16. So let's set up our equation and solve it. 3x plus 4 is equal to 16. Subtract 4, we get 3x is equal to 12. Divide by 3, and x is equal to 4. We're also supposed to find the value of y, and now we're talking about angles. And what do we know about the angles of parallelograms? Opposite angles are also congruent. So using that, we're going to set up our equation in a similar way. Y minus 60 is equal to 56. And now we're adding 60 on both sides. So y is equal to 116 degrees. In example 10, we are given the measurements of two angles only, and those two angles are next to each other. They are consecutive. What do we know about the angles of parallelograms? Consecutive angles have to be supplementary. That means these two angles together have to measure 180 degrees. And that information we're going to use to set up our equation this time. It's a little different than in the previous two cases. Now we are adding these two measures, and they have to add up to 180 degrees. So let's just combine like terms. We get 17x minus 24 is equal to 180. Now let's add 24 on both sides. 17x is equal to 204. Divide both sides by 17. And x is equal to 12. In our last example, we are given only measurements of the diagonals, or to be more precise, of segments that make up the diagonals. And we need to remember that in parallelograms, diagonals bisect each other. So that means both diagonals are now cut into two pieces that are congruent. And so we're going to find both j and k by setting up equations. 3j has to be the same length as 5j minus 9. So 3j is equal to 5j minus 9. Subtract 5j from both sides, and we end up with negative 2j is equal to negative 9. But the negative sign goes away as soon as we divide by negative 2. J is equal to 9/2, or 4.5. And k plus 10 has to be equal to 6k. So k plus 10 is equal to 6k. Subtract k from both sides. 10 is equal to 5k. Divide both sides by 5. 2 is equal to k. Alright, so much for this, and now go ahead and watch the second part of this tutorial.